Okay, we're still on question number one. We did, we answered the one thing, and then we did the parts A and B, and now we're on C. And C depends on your understanding of what you did in B, because they say you were given that as theta varies, L has a minimum value. Well, that makes sense, by the way. Show that this minimum value occurs when theta equals alpha, where this K equals 1 minus cosine alpha, 1 plus sine alpha. So I'm going to go back to the whiteboard again, and I want to kind of remind you that we know what L is. And L is this is C, by the way. We know L is a function of theta. And what's that function going to be? I'll write this down for you. It's 1 plus the tangent of theta plus the secant of theta plus K times 1 plus the cotangent of theta. We just derived this, by the way, plus the cosecant of theta. All right? So what am I doing over here? I gotta take its derivative, all right? And, one thing at a time. So L prime, we're differentiating with respect to theta. Well, the derivative of 1 is just 0. The derivative of tangent is secant squared. I'm going across this thing this way. So secant squared theta. Let me remind you, theta is between 0 and pi over 2. All right? Next up, the derivative of secant is going to be tan theta, secant theta. All right? Plus K. Then you can get derivative of 1. I did this, by the way. We're doing the K part now. Derivative of 1 is 0. The derivative of cotangent is going to be minus cosecant squared of theta. And the derivative of cosecant is going to be cotangent cosecant. I'm sorry, minus cotangent secant. Get my ratio right again. Sorry about that. Minus cotangent theta, let's see, cosecant. All right, so I'm going to look back at the question again. You were given that as theta varies, L has a minimum value. But my analysis for length is going to be on the interval between 0 and pi over 2. So really what I'm looking to do is, maybe I'll simplify this a little tiny bit. And it's going to be secant squared plus tan secant. Not sure if it's going to lead anywhere. Minus K, factor out minus 1. And then you get cosecant squared theta plus the cotangent theta cosecant theta. This is a long problem, isn't it? This was a competitive exam. It'd be tough, I'll tell you. At least for me, because there's a lot of tedious things that can make a mistake on. And what I'm going to do over here, I'm going to try to simplify what's inside that grouping symbol there. So secant squared plus tangent theta secant theta minus K. And the reason I want to simplify, I'm seeing that cosecant, which is really a sine squared on the bottom. And then you get 1 plus, well, I gotta be careful. I'm gonna write this down for you. I'm seeing it's gonna be cotangent, because that's cosecant's whatever sine, so I put another sign there, times the sine of theta. And the cotangent is going to be cosine of theta over sine of theta times sine of theta. That's just going to be cosine of theta. That's not so bad. All right, that did simplify, by the way. Then the question goes, what are you going to do about that? And this is problematic. I got to look at this thing and wonder what to do with it. I'm looking at it. And I'm trying to figure out what to do here. You know what I'm going to do? I'm going to factor out a secant now. So I'm going to factor a secant on from this. And you're left off with secant theta plus tan theta minus k, 1 plus cosine theta sine squared theta. Let's see if that goes anywhere. All right, so secant theta. Let's see, that's 1 over cosine. And they get 1 plus sine theta. Let me just stop for a moment. Yeah, it's not so bad. Minus k, 1 plus cosine theta over sine squared theta. Okay, I'm seeing something a little bit better. I'm seeing that maybe I could write this as cosine squared theta and 1 plus sine theta minus k. This is going to be 1 plus cosine theta over sine squared theta. I want to go back and read the question now because I'm wondering what I didn't do yet. Okay, I think I got some comprehension of what they want over here. This is a derivative over here. And by the way, the derivative is being analyzed between 0 and pi over 2. And there's going to be some minimum value over here. Before I do it, though, I want to claim, I'm really kind of looking at when this thing becomes 0. Because I noticed that, like, for example, the cosine curve between those two numbers is positive. The sine curve is positive. Everything looks great, right? So I'm just going to take this over here and set them equal to one another. That would make it a 0. So I'd see 1 plus sine theta over cosine squared theta would be the same thing as k times 1 plus cosine theta over sine squared theta. And I'm going to try to solve that for k now. And what do you get over there? You get 1 plus sine theta over cosine squared theta times sine squared theta over 1 plus cosine theta, and that equals k. All right, I'm looking at this, and I realize your goal over here, and I'm trying to figure this out right now. By the way, I know theta is between these two numbers over here, and they say it's some alpha value, or theta is equal to some alpha value. But I got to figure this out now, and I'm looking at it, and I'm going to, let's see what I'm going to do now. I'm looking at this thing, and I want to get it to look like what they have. And I'm going to multiply the top and the bottom by 1 plus sine. Not 1 plus, sorry about that. 1 plus sine theta. I did it again. I don't want that. 1 minus sine theta. 1 minus sine theta. All right, let's go through that. What do you get? And I'm associating these two over here to do that. Well, you're going to get this. You're going to get 1 minus sine squared theta, right, over cosine squared theta times 1 minus sine theta times, let's see, sine squared theta over 1 plus cosine theta. Well, I notice that this top over here is just cosine squared, so these cancel off. So I am seeing the 1 minus the sine, and now what I'm going to do over here is multiply the top and bottom of this, and this is equal to k, by the way, by 1 minus cosine theta. 1 minus cosine theta. Let's keep moving. What do you get over here? 1 minus sine theta. And over here, what do you get? Well, let's see. You're going to get sine squared you're going to get 1 minus cosine theta. This is equal to k, by the way. On bottom, you get 1 minus cosine squared theta. And what about that? Same thing as sine squared theta, so these things are canceling off. So we're left off with 1 minus cosine theta over 1 minus sine theta equals k. And that would make that thing equal to 0, by the way. And that's what they're saying over here. I'll go back and read it to you. It says you were given that theta varies. And by the way, it varies between 0 and pi over 2. And it says that L is a minimum. And the minimum, it says show that the minimum value occurs when theta equals, alpha. And by the way, what we're trying to do is we're trying to show this over here. But yeah, the theta would equal the alpha then if you want to replace it. Find a simple expression for the minimum value of L in terms of theta, in terms of alpha. And I think we just did that. And I want to tell you, I think we got that done. But now what I got to do is I got to plug it in. All right, I got to plug it in. All right, and to plug that in, let me take a think about that for a moment over here. I got to do L. That does look tough, doesn't it? So the K equals 1 minus cosine alpha over 1 plus sine alpha. Let me have a moment to think about that. And I got the K, and I guess I could write this down now. I could write down L of alpha, right? I got to go back, and I can't remember what L is, but I'm going back and read it to you. So it's going to be 1 plus the tan of alpha. It's going to be a lot of work. Plus the secant of alpha. And then it's going to be plus k. Well, this is k right here. So it's going to be 1 minus cosine alpha, 1 plus sine of alpha. And we're getting the minimum L now. And what do you get over there? It's going to be 1 plus the cotangent alpha, and then the cosecant of alpha. All right, the work is at hand now. And the work is going to be, oh boy, that looks like a really tough one, doesn't it? And let me just see if I can, you know what? I think I made a mistake in copying. Sorry about that. I'm going to go back and get my little eraser out. And I'm glad I noticed that because this thing would not lead to a very nice thing. And what I just noticed is I copied wrong. This is a minus sign. I'm just seeing that up here. It's what we just derived, by the way. Okay, so looking at this thing over here, I'm going to try to simplify this now. And this looks like it might be nightmarish simplification, but let's give it a shot. All right, let's give it a shot. And, one thing I'll do is I'm going to try to rewrite it so it's a little bit easier for me to handle. So tan I can write as sine alpha over cosine of alpha. And this varies from student to student. Some people say, I don't like doing what you're doing. You can do it differently. I'm telling you can't. It's going to be cosine of alpha. Boy, that looks pretty easy, doesn't it? Plus 1 minus cosine alpha, 1 minus sine of alpha. I'll do what's inside this grouping symbol. 1 plus, that's going to be cosine alpha. Running out of battery again. Hopefully I'll get to the end of this thing before it runs out. Sine of alpha. And then it's going to be plus 1 over sine of alpha. All right? I got to keep moving. And looking at this thing, I'm going to say the first 3 terms, common denominator of cosine alpha, and you would get cosine alpha plus sine alpha plus 1. We just did these 3 terms over here. Let's go to the next thing. This could be 1 minus sine alpha, 1 minus cosine alpha, and over here, common denominator would be sine alpha. And what do you get there? You get sine alpha plus cosine alpha plus 1. Make sure I did okay with that. Yeah, I see something now. What do I see? I see I can factor something out here. And let me write that down for you. And the thing I'm going to factor out is the cosine alpha sine alpha plus 1. And what do you get there? You get 1 over cosine alpha. I just did this guy over here. Then you get plus 1 minus cosine alpha, 1 minus sine alpha, times 1 over sine alpha. Well, it's getting a little bit smoother, but not totally. So I'm going to keep working on it until I see something nice. There's always something else to do, by the way, until I get to the end of it and I say, oh, there's nothing left to do. And look at this guy over here. Kind of looking at it, and I'm wondering what to do with this. And let me try this. All right, so I'm going to try to get this, and I'm looking at this over here, and I'm going to write down. This would be 1, and then I'm going to put down cosine alpha. Not much I can do about that. Over here, this looks complicated. I'm going to maybe write this a little differently. I'm going to write it as 1 minus sine alpha times sine alpha. This is kind of disturbing me here. I'm going to multiply top and bottom by 1 plus sine alpha. I don't know. Maybe it's not going to work out. Let's keep moving. Cosine alpha plus sine alpha plus 1 times 1 over cosine alpha plus. Now when I multiply this out, this is going to be 1 minus sine squared. And that's going to be cosine squared alpha. And then I'd get over here sine alpha. On top, what do you get? You get 1 minus cosine alpha, 1 plus sine alpha. Well, still looking at that, wondering what to do about it. And I'm going to keep working on it. And what do you get over here? Cosine alpha plus sine alpha. Kind of looking at that percent symbol. I know it's at 9% now, and hopefully I get to the end of it before that. And what do you get over here? 1 over, well, I'm going to common denominator. I'm going to say cosine squared, sine theta, sine alpha, I mean. What goes on top then? Cosine sine. And then I'm going to put this expanded form down of it. It's going to be plus 1. Let's see. There's going to be sine minus cosine. And then minus cosine sine. Yeah, I know I jammed it in there, by the way, but I notice immediately that these two are disappearing. And what do you get over here? I mean, a little bit smaller. And you get cosine squared, sine theta, I'm sorry, I put the theta down, I meant the alpha. Let me get the eraser out again. I'm so used to saying alpha, and then I'd say theta, cosine squared alpha, sine alpha. On top, what do you get? 1 plus sine alpha minus cosine alpha. Let's see what I got there. Let me think. Cosine, yeah, I think I did okay. I'm wondering where to go with this, though. I think it's going to work out nicer, but I don't know. What else could you do? I guess you could do, not much you could do here, is there? You know what I'm going to do? I'm going to multiply it out now. Cosine squared, alpha, sine alpha. And let's do this over here. You get cosine alpha plus cosine alpha, sine alpha. I just distribute that across those three terms, by the way. Oh, no, I didn't do the third one. Sorry about that. Minus cosine squared alpha. Let's do the sine now. What do you get? Plus sine theta. I keep on saying that, don't I? Alpha. Plus sine squared. Alpha. And minus cosine sine. And then I'll do this over here. I got to jam it in there. Plus 1 plus sine minus cosine alpha. All right, I'm going to start to cancel things off. I see this disappearing. I see this disappearing. And then I see those three terms left, don't I? Let's put that down then. And what are you left off with? Be careful about it too. Let's see. You get sine squared alpha. And then you get 2 sine alpha. Make sure I'm doing this right. And then you get 1 minus cosine squared. And that's going to be sine squared, right? 1 minus cosine and sine squared, so 2 of these. All right, what do you get in bottom? Cosine squared alpha. Well, things are getting a little bit smaller. I mean, I like that. If he's getting larger, I'd say this thing's going in the wrong direction. But let's write this down. I'm going to factor out a sine and a 2 alpha. And what are you left off with? Sine alpha plus 1. On bottom, you're left with a sine alpha and a cosine squared. And the cosine squared, same thing as 1 minus sine squared alpha. I'm going to factor that. This cancels off. And again, this alpha is between 0 and pi over 2. It's safe cancellation. You get 2 sine alpha plus 1. On bottom, you get 1 minus sine alpha. And you get 1 plus sine alpha. It's 7% now. Let's hope this thing, just like there's nothing left to do. These cancel off, not conditionally either, because the alpha is between 0 and pi over 2. And what are you left with? I think you're left with the final possibility at this point. I can't see anything else to do over here. You might say, no, I'm going to do something with the bottom, but there's not much you can do about that. And I'm done. Thank you.